So folks, we're going to just quick look at doing a dissociation equation and then calculating the pH for one of the problems on the calculating pH for strong acids worksheet. So I've jumped to C because it starts looking at values that aren't going to be some factor of 10. So I'm looking at the one that says, gives us the ClO4 concentration of 5 times 10 to the minus 4 moles per liter. So the first thing I want to point out is that when we're trying to calculate the pH, we need the hydronium ion concentration or the hydrogen ion concentration. So we need to derive that from this HClO4. Quick note, the title of the worksheet references strong acids. This is a strong acid, and here's what we know. All strong acids will undergo 100% dissociation. So I'm just going to quick write a dissociation equation for perchloric acid here. So we know when we put this in water, it's going to break down into hydrogen ions and the remaining chlorate ion. So we should just note these are aqueous. And all of this is going to break down into hydrogen ions and the chlorate ions. So that means whatever the concentration of this is, 5 times 10 to the minus 4 moles per liter, you're going to have the equal amount of these two ions because of the 1:1:1 ratio. So that means you're going to have hydrogen ion concentration of 5 times 10 to the minus 4 moles per liter, and the same for the chlorate ion. Now, what's true here is we don't really need the chlorate ion, but we're keeping note of it. Okay, so now we've derived the hydrogen ion concentration. Because it's a strong acid, the hydrogen ion concentration is equivalent to the concentration of the initial acid. So then we're going to plunk that into our pH equation. So remember, it's the negative log of the hydrogen ion concentration. So I'm actually going to take that 5 times 10 to the minus 4, plunk it into our equation here. This is where you need to get to know your calculator, and I'm going to make sure I show you guys tomorrow when we're doing this in class. Depending on your type of calculator will dictate how you type this in. So with my calculator, I have the display screen at the top. If your calculator has the display screen at the top, it shows you your calculation as it's going. You're going to type it in exactly as it appears here. So I'm literally going to type negative, not your subtract sign, your negative sign. I'm going to look for my log button. Mine's here. Look closely. Yours will be somewhere there. You just maybe have never used it before. And then it already prompts me to start putting in a number. So we have to take the negative log of some number. We're going to use the 5 times 10. So I'm going back to our study with moles, we're going to be using that exponent button. 5 times 10 to the negative 4. And I'll hit equals. It tells me my pH is 3.30. So again, I'm taking the negative log of 5 times 10 to the minus 4, and that's going to give me 3.30. If your calculator lacks this display screen, it's very likely that you're going to have to type the question in the exact opposite order it appears. So if your calculator lacks that display screen, it's very likely that you'll have to type in your number, then hit log, and then flip the sign by using your negative button.